This is section 2.3, part D. We're going to continue looking at modeling, only this time we're going to give ourselves the option of linear, exponential, or quadratic models. So 3 to pick from. Okay. One thing I would like to mention, and that is that exponential and quadratic models can actually have something in common. If you think about it, a quadratic model may look like this, and an exponential growth function may look like this. If we only have data sort of towards the end of the time frame, we may only be seeing part of the growth. And the quadratic and the exponential functions both increase with sort of a curve to them as they go off towards higher and higher values of x or time, whatever we're working with. So it may not be possible to predict precisely what's going on unless we know a little something about the trends. Same thing can happen with exponential decay. This part of the quadratic graph and this part of the exponential decay graph look very similar. And so we may not know, unless we kind of can predict what's going to happen to the future, which model we should pick. So when we go ahead this time, we're going to go ahead and we're going to not only look at the scatterplot to help us decide what kind of model, but we're also going to think about what do we think is going to happen? Did something go down and come up? Or are we expecting something to continue to rise or continue to fall? And we'll pick our model accordingly, not just based on the correlation coefficients. The first set of data for various years records the revenue in millions of dollars from the sales of blank audio cassettes. Our goal is to predict the sales in 2006. Clearly, we've got decreasing revenue, which makes sense. People don't use audio cassettes all that much anymore. So our kind of thought process is, are we looking at part of a quadratic model, or are we looking at part of an exponential, or are we actually looking at a linear? Let's start with a scatterplot. Let's see. I'm going to go ahead and let T be years after 2000. So 0, 1, 2, 3, and 4. And I'll put my data in. And as far as the window, 0 to 5 will cover my times. And 0 to 200 maybe. Oops, the scale is 1. 0 to 200 with a scale of 10 is what I'm going to do to cover my revenues. I still have my plot turned on, nothing in my y equals, and there's my graph. All right, this one is, I'm going to have to look kind of carefully at this one. I wouldn't argue that a linear model isn't terrible. It's not, not really a big curve. But I am starting to see toward the end here, instead of continuing down straighter, it feels like it's starting to level off. So I think an exponential might be the better bet, or possibly a quadratic. Looks like there's a little curve to it. Now, which situation am I in? Would I be expecting the revenues from audio cassette sales to go back up in the future, or to continue to come down? Well, at this point, I don't see audio cassettes making a big comeback. So I'm thinking that based on my future prediction, I believe it's going to keep on coming down. And I think an exponential model would be the better course of action here. All right, so in our stat again, we're going to calculate. Go on down till you find exponential regression. And there we go. In general, y equals ab to the x, just like the calculator says. And let's see if I can get this one. It's a little bit lighter for you. There we go. My y values are the revenues, so I'm going to call that r. And let's go with 160.059 times 0.793589 to the t would be my input variable. And I'm putting that forth as my potential model for the revenue from selling audio cassettes. All right, we were trying to predict the sales, or the money from the sales in 2006. So if I just plug in 6 for T, see, our prediction would be, oh, and by the way, before I get rid of this, I do have a really good R-squared value, the correlation coefficient, very close to 1. But again, I'm also thinking, I can also see that it's going to follow the trend that I'm predicting for the future. So both good things. All right. So let's see, plugging in our 6 years. I'm looking at, let's see, they rounded revenues off to the nearest whole number of millions, so I'm going to do the same. I'm going to call that 40 million. In 2006 would be the prediction based on our model. All right, in the next problem, we have a chart showing U.S. oil production for various years. And let's see, they started in 1991. I'm going to go years after 1990. It's just easier for me to subtract. Notice that you can pick anything you want for the starting year, unless they tell us, and they didn't. So I'm going to go with 1, 5, 9. 13, 17, and 21 years after 1990. And once again, I'm going to start just by putting the data into the calculator. In terms of my window, let's see, we got 21 years. I'm going to go 0 to 25. Scale of 1 should be fine. And 0 to 10 would cover my Y values. And there we go. All right, couple things about this. First of all, I'm going to notice that it's really not perfect for anything, but this is one of those where I'm really kind of saying that either a quadratic or an exponential model is probably a reasonable fit for the data. What's happening here is right at the end, it looks like it started to come back up. That might suggest quadratic. It's gone down, starting to come back up, so sort of a very shallow parabola. That's a possibility. The other possibility is that this year was just sort of an exception, and what we've really got is just kind of a slowly decreasing exponential function that maybe would even pass right between those 2 points. I'm going to need to use a little bit more information to decide which way to go on this one. And so if you kind of check on oil production, and again, I am making this video in 2018, the oil production this year is actually predicted to be somewhere in the neighborhood of 10 million barrels. And so it has indeed continued to go up. Based on that knowledge, I'm going to say, yeah, if it's going to keep on going up, then the quadratic would be the better model. Had it leveled off or continued to go down, I probably would have chosen the exponential, even for the exact same set of data. So, given our knowledge, what we can just find online, we are going to choose quadratic this time. We know that production actually increased more after 2011. And so in my stat, I'm going to calculate a quadratic regression. And there we go. Let's see, our Y value is really the oil production. I'm going to use P for production. The A is 0.00, I'm going to call that 91. And our X is actually T, the time, squared. Minus, if we go with 4 decimal places, 0.2898. That would be T, plus the C value, 7.7539. And again, I'm just trying to be consistent, choosing 4 decimal places each time. So there's my model. And I guess I didn't even ask us a question on that one, but let's go ahead and let's do one that we can all be on the same page for. Let's go ahead and use this to predict the oil production in 2015 based on our model. So let's see, 2015, that would be 25 years after 1990, so T would be 25. And if I just plug 25 in for those T values, I'm getting about 0.6, what do we have, 2 decimal places, 6.38 million barrels. Would have been this model's prediction for 2015. All right, that is the end of section 2.3, and so we'll come back next time for 2.4.